This is a Friday Shoes production. It's lesson 12-2 in our books on page 637. And our target today is I can find the probability of independent and dependent events. Before we talk about those, let's talk about what a compound event means. And a compound event consists of two or more simple events. For instance, flipping a coin and pulling a card out of a deck. Those are called simple compound events. For independent events, the outcome of one event does not affect the other event. For instance, me flipping a coin does not affect the probability of me pulling a card out of the deck. They're independent from each other. Now, probability of independent events can be found by multiplying the probability of the first event by the probability of the second event. So simply, we calculate the two probabilities of the events that we have, and then we multiply them together. Let's look at an example. It says one letter tile is selected and a spinner is spun. What is the probability that both will be a vowel? Well, first off, let's look at these letter tiles. You can't see them. It should be in a bag and it should be randomly selected. So you can't actually pick which one you want. It's just randomly picking that. And then of course the spinner, you spin it and you randomly get whatever you get. So what is the probability that both will be a vowel? Well, let's calculate the probability of picking a letter tile that is a vowel. And when we do that, we have two vowels in that, let's call it a bag there, out of the 7. So the probability of selecting a vowel from there is 2/7. What about the spinner? Well, on the spinner we have two vowels out of 6. So we have 2 out of 6, which is actually 1/3. We have those two probabilities now. And to actually find out getting two vowels, the probability of getting two vowels would be 2/7 times 1/3, which would be 2/21. That's the probability of getting both vowels when you select. How about you give it a shot here? Pause the video and try these two. Come on back, see how you do. Now it says the probability on A, it says probability of both letters are A's. So you pick out of the tiles and then you spin. What are the chances you're going to get A's on both of them? Well, let's calculate the probability of the first event happening, meaning you selecting an A out of those tiles. Well, there's only one tile that has an A out of the 7, so it's 1/7. That's the probability. How about on the spinner? There's only one A out of the 6, so it's 1/6. Now take those two probabilities to find out getting an A on the tile and on the spinner. You have to multiply those two together. 1/7 times 1/6 is 1/42. That is our answer. How about B? How about probability of both being consonants? Well, let's look at the tile first, and it's selecting a consonant from the tile, and you notice it's 5/7. There's 5 consonants out of the 7 total tile there. And then the second would be the spinner, and there's 4 consonants out of 6 total, and that's 2/3. We reduced it down. So we would take those two and multiply them together to get what the probability would be of both of them being a consonant, and that comes out to be 10/21. All right, how about a test example? It says a spinner and a number cube are used in a game. The spinner has an equal chance of landing on one of 5 colors, red, yellow, blue, green, and purple. The faces of the cube are labeled 1 through 6, the regular die. What is the probability of a player spinning blue and then rolling a 3 or a 4? I'm going to give you choices here. Well, first off, we got to remember what we're looking for. It says we're looking to find the probability of spinner landing on blue and then rolling a 3 or 4 on a number cube. So these events are independent because spinning the spinner does not affect the outcome of rolling a number cube. Given that, here are the steps we go through. It says first, find the probability of each event. So what's the probability of spinning blue on that spinner? Well, there's 5 colors. One of them is blue, so it's 1 out of 5. There's your probability there. How about probability of rolling a 3 or 4 on the die? Well, 3 or 4 means you can either get a 3 or a 4. That's 2 sides that are okay. So 2 out of the 6 sides, which reduces to 1/3. So that's your other probability. Then, of course, find the probability of both events occurring by multiplying those two probabilities, 1/5 times 1/3, and that's 1/15. So the probability is 1/15, which is the answer C, of course. All right, how about you give it a shot here? Pause the video, come on back, see how you do. A game requires players to roll 2 fair number cubes to move the game pieces. The faces of the cubes are labeled 1 through 6. What is the probability of rolling a 2 or 4 on the first number cube and then rolling a 5 on the second? Well, let's look at that first roll of 2 or 4. That means you're looking for 2 or 4, so that's 2 out of the 6 are going to be okay, which is actually 1/3, but I'm going to leave it as 2/6 to show you. You don't really need to reduce it while you're working on this. And then the second, rolling a 5 on the second die, well, there's only 1 5 on the number cube out of 6, so we have 1/6 for that probability. Now, what is the probability of both of those things happening? 2 or 4 and then a 5? Well, step 1, multiply those two together. So 2/6 times 1/6, and that equals 2/36, but we can reduce that to 1/18, and of course, there's the answer, J. All right, lastly, if the outcome of one event does affect the outcome of another event, the events are called dependent events. Probability of dependent events are stated as such. If two events, let's call them A and B, are dependent, then the probability of both events occurring is the product of the probability of A and the probability of B after A has occurred. And there are the symbols for it there. Again, the best way to look at this is an example. All right, so take a look at our real world example here. It says there are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Megan selects a piece of fruit at random, and then Karen selects a piece of fruit at random. Find the probability that 2 apples are chosen. Now, when you look at this and you think to yourself, well, I could grab one of those and I'll know exactly what I'm grabbing. Let's do it this way. Think of this as, this is your reward here. And you're going to be picking an orange, banana, or an apple, but let's say the names of those. 7 pieces of paper would have banana on it, 4 would have orange on it, and 5 would have apples on it inside of a bag. So you're actually not feeling the actual apples or what have you. These are randomly selected. So you're not actually feeling them. That would be not random. You know exactly what you're getting. So you don't know what you're going to get. But what is the probability that 2 apples are chosen then at random? Well, since the first piece of fruit is not replaced, the first event affects the second event. So when you actually select, let's say, an apple out of there, well, now it affects the numbers for the next person that comes along and picks. And that's what's happening here. So we call these dependent events. Let's see how it looks mathematically. Well, first, let's calculate selecting an apple on the first pick. When we do that, you look at the apples. There's 5 apples in there out of 16 total fruit. So it's 5/16. Pretty simple. Now you've got that apple. It's taken out. It's not put back in. Now, what's the probability of getting another apple? So we get that second apple. Let's calculate that one. Notice now, we have to look and think, one of the apples has been removed. So I'm going to actually cross it out so physically you can see. There's only 4 apples left now. Out of, and you've counted all the fruit, you've taken one out. There's 15 there. So notice how that first event did affect our second event. So we have 4 apples out of 15 total fruit now, not 16, because one of those apples is gone. So we don't have that total. So now all we have to do is multiply those two numbers, 5/16 and 4/15, to get our total, and which is the probability of 2 apples being selected. And again, these are dependent events, and that's why those numbers have changed a little bit. So when you multiply those, we get 1/12, and that is our answer. Picking 2 apples is the probability of 1/12. All right, how about you give it a shot here? Find each probability. It's the same exact example. We got 4 oranges, 7 bananas, and 5 apples in the fruit basket. Megan selects a piece of fruit at random, and then Karen selects a piece of fruit. Now, D says, what's the probability of 2 bananas being chosen? Again, you give it a shot, pause the video, come on back and see how you do. Well, there's 16 fruit to begin with. And when you select 2 bananas in that order, let's see what happens. What's the probability of the first thing happening? Well, if you remember, there's 7 bananas out of the 16 total. So it's 7/16. Now, assuming that that banana has been taken out and the first, what is the second probability? Well, the second banana, we have 6 left. 6 out of 15 fruit. Not 16 anymore because that one banana has been removed from the first. So now we have 7/16 and 6/15. So we have, what's the probability of 2 bananas? We have 7/16 times 6/15, which would equal 7/40 after you reduce and multiply. There's our final answer. The probability of picking 2 bananas is 7 out of 40, or 7/40. All right, how about E? Same story, starting fresh. You got 4 oranges, 7 bananas, 5 apples in the fruit basket. And you want to have Megan select an orange and then Terrence select an apple. What's the probability that's going to happen? Well, what's the probability of the first thing happening, the orange happening? Well, there's 4 oranges out of 16 total fruit. Remember, we're starting all over here. Got 16 fruit back in there. 4 out of the 16 are oranges. Now, assume that one of those oranges has been taken out. So now, what's the probability of picking an apple? Well, how many apples are in there? We got 5 apples in there. But notice that the bottom has changed because I have already taken an orange out. It's been taken and gone. So we have 15 left. So it's 5 out of 15, not 5 out of 16. That's a big mistake a lot of kids make. So we have 4/16 and 5/15. To find out what's the probability of picking an orange and then an apple, it would be 4/16 times 5/15, and that would equal 1/12. Don't forget, you can always rewatch the video, or you can look at the examples in the book, or check out the personal tutor videos on the online textbook. And this has been a Friday Shoes production.